Independent and dependent events.
Hi, Brayden.
It's kind of like independent dependent variables. Only we're not talking about variables, we're talking about events. If events are independent, that means that one happening does not affect the other one happening. One outcome has no impact on the outcome of another. And if events are dependent, that means that one outcome does have an impact on the other. It usually comes down to whether or not you have replacements, meaning if you take something out and put it back, or don't put it back. That's usually what determines if something is or is not independent. So we'll do some examples. If you flip a coin and then roll a dice, the outcome of flipping the coin does not impact how you roll the dice. These are independent events, because this one does not affect this one. If you pick a card from a deck and then your friend picks a card, are those independent or dependent events? How come? He can't pick the card you picked. Right? You had a 1 in 52 chance of picking whatever card you picked. Your friend now has a 1 in 51 chance of picking whatever card they picked, because they can't pick the card you picked. They're dependent. You flip 9 heads in a row on a fair coin, and you flip the same coin one more time. Are you more likely to get a heads, less likely to get a heads? No impact. Exact same probability. Yeah, and odds, sure. This is independent. Just because we got 9 heads in a row doesn't mean we're more likely to get a tails. And just because we got 9 heads in a row doesn't mean we're more likely to get a heads, assuming the coin is actually fair. Now, it might be if you flip a coin 100 times and you get 100 heads, you will no longer think that coin is fair. Because the probability of getting 100 heads in a row is 1 over 2 to the 100th, which is, very small. But with just 9 heads, it's doable. That can happen. So, if the coin is actually fair, those events are independent. Some people think, well, since I flipped so many heads, aren't I due for a tails? And it doesn't work that way in the short term. It doesn't tell you anything about your next flip. You might think over your next 10 flips, you might get more tails, and that's a more reasonable assumption, but you know nothing at all about your next single flip. You pull a card from a deck, look at it, and put it back, then your friend pulls it, or then you pull another card. Independent or dependent? Independent, because the card you picked is back in there. Some people say, well, wouldn't you try to not pick that card again? Maybe, so we're assuming like the card's shuffled or things have moved around, you don't have control over that. But when you pick another card after putting it back, it's still independent, and that's where I talk about replacement. When you put the card back, then things can still be independent. When you're finding probabilities of independent events, the P of A and B is P of A times P of B. So the probability of A and B happening is the probability of A happening times the probability of B happening. So suppose you're rolling 2 dice. I'm going to change this word from and to then. You roll 2 dice. What's the probability you roll a 6, then you roll a 3? One of 6 times 1 out of 6. You have a 1 in 6 chance of rolling a 6, and a 1 in 6 chance of rolling a 3, so it's 1 in 36. That should be a 6. The reason I had to change it from and to then is because if it was and, you could roll 6 and 3 or 3 and 6, like a 2 out of 36. So I made it then. Rolling a 6 and rolling at least a 3, what's the probability of that? Why 1/2? At least means 3 or bigger. 3, 4, 5, or 6, so 4 to 6. So it's 4 in 36, which is 1 in 9. Which is 11%.
Won't you back up for a second?
I will. Push it all the way up. So whenever you're trying to find probabilities of one single thing happening, it's never that good. Like rolling a 6 and then at least a 3 is still just a 1 in 9. Because rolling a 6 isn't very likely. It's not super unlikely, I mean 17% almost. But like just rolling a 6 isn't super likely. A 6 and something else becomes way less likely. But usually you don't care about just one thing. Usually there's a few things that you would work and you have to add up those probabilities. Like we said, probably rolling a 6 or a 7 or an 8 or whatever, you add up those things. Yeah?
So like with the lottery, is it, there's like a lot of numbers on each thing, does that make it more or less probable, or is it the same?
What do you think?
Like it would be like a 1, like number 2, or like number 2 zillion something.
Mm-hmm. What do you think?
Less.
Yeah, way less. And we'll do that in a second. See how unlikely it is. Yes, Cameron?
So, and then, which one is it for? Which one do you multiply it for?
Kind of both.
But then why does like the formula say that?
Because the way that it works with dice is that like 6 and 3 could be interpreted rolling a 6 and a 3 on your first roll. Or like 1 could be a 6 and 1 could be a 3. And so with like the same event happening or same thing done twice, and can be kind of ambiguous. Like if I said rolling a 6 and flipping a heads, then the word and doesn't matter because they're separate things entirely. Yeah, so you have to kind of be specific with your language, and I had to clean this up. Okay, dependent events. Dependent events are when one event does impact the other. And they have basically the same formula. You still multiply. It's P of A times P of B. That little dot got when I switch screens. P of A times P of B, but it's called P of B after A, meaning you find the probability of B after event A has already happened. It's often written like this with a line. As I said, probability of B given A. That little line there means the word given. Means find the probability of B given event A has already happened. So what's the probability that you pull a jack and then a queen? What's the probability that you pull a jack and then a queen? Know this. What's the probability that you pull a jack?
1/52 times 4.
4 out of 52. There's 4 jacks. And then pulling a queen is 4 out of 51 because you already pulled out the jack. Yeah. That's what makes these dependent. Right, there's one less card for you to pull from on the second one. 4 and 52 the first time, 4 and 51 the second. Does that make sense?
Yeah.
Thank you. How about probability of doing a spade, then another spade? Your first pull has a 1352 chance, and then 12 out of 51. Because there's one less spade to work with, and one less card overall. And what if we did probably doing 5 spades in a row? Just keeps going, yeah. It's 13, then 12, then 11, then 10, then 9, 1, 2, 3, 4, 5. Over 52, then 51, then 50, then 49, then 48. And look, it looks rather combinatoric. It's like a factorial on top and a factorial on the bottom. Yeah, this up here is 13C5, and this down here is 52C5. No, P's. Those are P's. No, they're C's. Order doesn't matter. 13C5 and 52C5. And then a flush is when all suits are the same. Sorry, all cards have the same suit. Pick 5 cards, they all have the same suit. It doesn't matter if it's spades or hearts or diamonds or clubs. So for a flush, it'd be this times 4. Because it could be a spade, a heart, a diamond, or a club. There's 4 possibilities, so a flush is 4 times. But they're dependent. Every time you do something, it goes away. You lose an option. Questions there? Okay. Complements are next. Complements with an E are different than complements with an I. Complements with an I is like, you look nice today. That's a compliment. Complement with an E is leftovers, things that aren't being used in your event, but are in your sample space. So for example, the complement of rolling a 5 is not rolling a 5. And the complement of rolling at least a 5 is rolling no more than a 5. A complement is like, in geometry, complementary angles are things that added up to 90. So the complement of 60 was 30, because 60 plus 30 was 90. It's those two things together get you your whole sample space at 90 degrees. Complement isn't the same as opposite. We can't call it opposites because the opposite of rolling a 5 could be considered rolling a negative 5. So rolling negative 5 doesn't make any sense in this scenario, but there are somewhere it does. It's important to understand that the probability of an event happening plus the probability of the complement of the event happening is always 100%. It's like you have your the probability of A and the probability of everything else. And those two things put together is every option, which is 100%.
Like, so it's not. So if you don't roll a 5, then you just roll something else.
Complement is like something else.
It's not a specific thing, though.
Well, it is. In that case, it's 1, 2, 3, 4, 6.
Oh.
So maybe not one specific thing, but it is a specific set of things. So what's the complement to drawing a spade?
The other 3.
Not drawing a spade, which could be said as what?
Club.
Yeah, card down the club. What's the complement of flipping a heads? Flipping tails, or not flipping heads? What's the complement to the Blazers winning their basketball game? Blazers losing. Not everyone else winning, because we're not playing the Cavaliers and the Spurs. Right? They're just playing one team at a time. So the complement to the Blazers winning isn't anybody else winning, it's just Blazers losing. Or Blazers not winning. Or you could say Blazers opponent winning. What is the complement to the Timbers winning their soccer game? No.
Timbers not winning.
Correct. What's the difference?
That's what I'm using the opposite.
You can tie in soccer. That's the difference. In soccer, you can tie.
There's no, like, overtime rate?
There is, but if you go through extra time and penalty kicks, the game is still tied, you stay tied. Yeah?
But then isn't that another option? Like, is it another option to
But they didn't win.
the complement is like tying and losing?
Or losing. Correct.
Wouldn't it be they just didn't win? Because tying isn't winning.
Yes, so that's why we would say this as not winning. But we could say it as losing or tying. Okay? Both of these things are part of the complement, but they don't make up the complement entirely. So the complement is just the word not. It's really just like what isn't happening. And in fact, we use this little symbol here to mean not. So this is, if I say like, this means not A. That little wavy symbol is not A. Complement just means not. And for what it's worth, people complain about soccer because you can tie, but you tie in football too. You can't in college football, but in pro football there's a tie last year for the first time in like 12 years. They have 2 overtimes, but after 2 overtimes it's a tie. But in college football you play until somebody wins, like Kansas playing. Because we like wins and losses better than ties. But NFL
I know,
changed.
but like NFL, I don't know what it
They
is.
just kind of changed it. Okay, we did this yesterday, so I won't talk about it today. We'll do 2 more problems, and then I'll let you work on stuff.
Oh, sweet, I just finished.
Yep, you were just doing this. A committee of 10 people is to be chosen randomly from 12 women and 8 men. Problem 1. How many ways can this happen? Cool, lots of stuff. Julie, what do you think? Why?
Because there are 10 people chosen from the 10
Well, what you're saying right now isn't what you described. Like 10 times 20 wouldn't be what you just said. It's not that. No. Yes.
Would it be 20P, 10 or 20C?
Is it P or C?
It doesn't describe if there's different.
Right. If I'm picked first for this committee or I'm picked 8th, I'm still on the committee. All spots are the same. So it's a C. It's 20C 10. It's a combination. It doesn't matter which order I get picked in if I get picked or not. Out of 20 people, we're choosing 10 of them. And And 20C10 is not a crazy number, but it's a pretty big number.
Wait, you can do that on your calculator?
Yep. I showed it on the video.
Oh,
Do you have the I-
Nope.
Go to math.
The last two videos.
I have a question. So I know how to do that, but the exclamation point, is there a way to get it faster?
I don't think so. You can do this.
I have clicked so many times.
Are you going through your catalog? Are you doing it?
No, I'm
No.
pushing math.
So here's what you do. I do like 20, I do math, and I go left, and then I press 4. 20 math,
Oh,
left
see,
4.
I have like 5 options.
So we
So
press-
if I go left,
So press 5. Okay, then press left twice. You're complaining about pushing one more button. I'm not going to hear those complaints.
Okay, well, like, I'm not as fast as
Okay,
you.
so.
But you could be, right? I didn't start this fast. You can get there.
Go over to probability, PROB.
This
And
is our sample space.
B.
Okay? All the next problems we do when we're finding probabilities will be divided by this number.
Is it math or is it
What, 55?
Doesn't matter. Basically,
No, that's sample space. SS for sample
Oh,
space.
I was like, oh.
Ah.
This is our sample space.
Because you did P. Because.
We'll do C on all of them.
For this problem, always C, yes. Okay, what's the probability the committee has exactly 3 women? How do we find this? Remember, we have to find the number of ways we could get 3 women divided by the number of ways anything could happen.
12 C 3.
Out of 12 women choosing 3,
And then divide it over all of
the
them.
20 C10.
Yeah.
And this is a little bit incomplete. It's a very good start, but it's a little bit incomplete.
Do you have to put the other people in too?
The complements.
Or,
Yep. If we're picking 3 women, that means we're also picking 7 men. And we have to account for them also.
Ah.
Times.
Something like
Why would that be?
Wait, what?
I'm going to do one question at a time here, okay? So first of all, it's times because for every single combination of the ladies, there's this many combinations for the boys.
I know, but I
Like
feel
like
it
back
would
in
be
this problem,
add-
but back in this problem, did you get why it was times?
Oh. Yeah.
Because, you know, like if you're here and your friend's here, everything behind is getting multiplied. So it's multiplied. It's the fundamental counting principle that was in a video ago. And then, you got a question? Okay, Ms. Cameron?
How did you get to 7?
If we're picking 3 ladies, we're also picking 7 men,
Oh.
which is out of 10 total. Out of 10 total. So if we're picking 3 ladies, we also have to pick 7 men. We have to count for all. So here's the event of picking the women, but also the complement. If you pick 3 women, then you're also picking 7 men. Does that make sense? So we'll calculate that.
Do you have the answer to this worksheet?
Nope.
Wait,
Mm-hmm.
for
Yeah.
number 1, why did you get 55?
I didn't. That's SS for sample space.
Okay. Wait, what is this then?
Do you have to put that there?
I did that to point out that every single time I do one of these problems here, it's divided by this number.
Oh.
Okay, that'll always go on the bottom. That's why you find it first. The sample space is all the possibilities. You have to know that to find a probability, so always start with it. This works out to be about 1.1%. A little, about 0.9%, sorry, not 0.1, 0.9%, a little under 1%. So, to recap here, this was our sample space, meaning how many options are possible. And that will always go on the bottom of these fractions when finding probabilities. Probability is the number of ways the event can happen over the total ways in the sample space. This is how many ways I can pick 3 women. This is how many ways I can pick 7 men. Because I'm picking 10 people total, 3 women and 7 men. Yeah.
Why can't you just have the
because that's way fewer possibilities than how I could actually pick everybody. Like,
Include everybody else.
because you have to still pick everybody else. Yeah. Okay, try 3 on your own. I can't. Take a second and try 3.
I know, right? Can I use it?
I'm sorry, what? I might as well solve it. No reason not to.
Okay, just do it.
Go for it.
Is it 8C3 times 12C7 over 20C10?
It is. Out of 8 guys, we pick 3. Out of 12 ladies, we pick 7. There's 20 Z10 total ways possible. Eight C3 times 12 C7 divided by 184,756. Much more likely, 24%.
And so this part, you don't have to use it, parentheses or anything.
No. Yeah, the NPR, NCR buttons are the way to do it. Okay, what's the probability you get 5 women exactly?
What do you mean by are choosing that?
On the homework, don't do both. Just do one.
Oh.
And that was me like building my way up. Okay?
Oh.
Yeah, so in the homework you'll do this part, then do this part, and put them together for one problem. What's up, Julia?
Put 12 before C. Why would you put?
Okay, yeah?
Is it 12C5 times 8C5 for the hemispheres?
It is. Yeah, over 184,756. Are there questions there? So you've got a few problems like that on your homework. And you've got a few problems like this on your homework. Powerball. This is actually how Powerball works. There's 2 buckets of numbers, of balls, ping pong balls, whatever. And the white balls are numbered 1 to 69, and the red balls are numbered 1 to 26. With Powerball, you pick 5 numbers, or you pick 6 numbers. 5 numbers for the white balls and 1 number for the red balls. And if the 6 numbers you pick match the 6 numbers that came up there, you win the jackpot. Yes, Oren?
Why 69.6?
I don't know. Probably, well, I'm sure, like, I know in this, that's the best way for the lottery to maximize their income. To make it just likely enough that people will play because they're suckers, but not so unlikely that no one ever wins, but not so likely that people do win a lot. It's just the magic number for them, which I'm sure they did a ton of analysis to find out. Yeah?
Does the order of the white balls matter?
Great question. No. So this is important. If I pick the numbers 1, 2, 3, 4, 5 on the white balls, and it pops up 5, 1, 3, 2, 4, I still win. Okay? The order doesn't matter. If order did matter, this would be essentially impossible. Okay, so the order doesn't matter with the lottery. If you match the 5 white numbers and the 1 red number, you get the jackpot. But if you match like just the Powerball, the red ball is called the Powerball. The whole game is called Powerball, but the red ball is called the Powerball. If you match just the Powerball, you get like $7. And if you match 4 white balls and the Powerball, you get like $50,000. But if you match all 5 white balls and the red Powerball, then you get the jackpot, which can be, I mean, it's been as high as like 420 million, I think.
What's the most recent one? What's it like? 900 million?
And I don't think it was that high. I could be wrong. Look it up if you want. Okay, problem 1. How many combinations are possible?
I mean, it's 69C5.
69C5. Out of 69 white balls, we choose 5 of them.
26C.
And out of 26 red balls, we choose 1 of them.
The Powerball in January is 1.6 billion.
Billion? Wow, okay. That's the biggest I've ever heard of. I'll talk about how that works in a second. 69C5 times 26C1 292,201,332. Hmm, 292 million different combinations.
Wait, so
A
can
lot.
more than one person can
Yes,
allow something?
it does. It's split.
Oh, really?
Well, first the government takes the
And
account, then they split it. In the 30 to 40 range, I think.
Wait, would they get more if they split it before they split it with each other?
I'm not sure what the order is. My guess is the government takes it after it gets split.
So they get more.
I don't know. We'll think about that later. Yeah?
You know, on like the Price is Right, when they get like a jet ski, do they like have to like,
They pay taxes on that.
they do pay
Yeah.
taxes on it?
They can either take the jet ski itself or take the cash value of the jet ski, and then they pay taxes on it.
Oh,
Either.
really?
Mhm.
You don't even have to take it?
I think you have that option.
So I know on the Price is Right, a few years ago, like families would go under, like paying off their new cars.
During your stuff. Yeah. You get your stuff for your tax time.
Or like with,
Sure.
Like, whenever they get like a barbecue, if you're like, oh, I want a barbecue. And they start saying, that's not good.
Yeah. Okay, I have a problem too. What's the probability you win the jackpot?
Wait, and then go back.
does it depend on how many people enter?
No, you win whether or not people enter.
Like one in that many.
One in that
Isn't
many.
it? Yeah.
It's one, because there's only one winning combination. Right? One winning combination, so it's 1 in 292,201,338.
Does the number change every day, or
What number?
does the Powerball number change, or does it stay until someone gets it and then it changes?
They run the Powerball, they announce the numbers, and they let it sit for some period of time. And if nobody claims a victory, a jackpot in that period of time, a few months later they do it again. So sometimes, like, the Powerball company knows if a winning ticket was sold, and they actually know like what state it was sold in.
They know what store it's sold in.
They do know that. I don't know if they announce that always, but they know it because they kind of don't want people to claim a win. Because what happens is if nobody wins the jackpot, they take all that money and pile it on to the next one. So if nobody wins the jackpot for 10 or 12 or 15 Powerballs in a row, the pot gets really, really big. And then more and more people start playing because they want to win more money. And that's why they picked these numbers kind of specifically. They want it to grow really big because then more people play, but they don't want it to be impossible. So they have to kind of find the right happy medium. So the probability of you winning is 1 in 292 million, meaning if you bought one possible ticket for every combination, you would lose money. If you bought the 292 possible tickets that could win, when you won, you would still lose. Yeah?
So what would happen if you get all 5 for like balls, but it is
You get like $100. There's some scale. It might not be that low, but
Yeah.
the Powerball is the valuable one. The red ball is the one that makes you money. Yeah?
So like, well, this is not, it was kind of about the Powerball in general.
Mm-hmm.
Like, how do you think like it like got started, like got so popular? Like, do you think someone was just like, oh, like all the money that people like put into something, like one person will get out of it? And
Yep.
then just,
It got started because people know people are stupid. People will try and win a jackpot when their probability is 1 in 292 million. So basically, it's like somebody who can do the math is like, if I get all of you to give me $100, and I give one of you $1,000, but I get to keep the rest, I'm gonna make a lot of money.
how do you think like the person?
I think these things start a long time ago and they
Yeah,
grow.
yeah,
I think
how
like in
do
ancient
you
times,
think
there were things kind of like this. And they just keep getting more and more sophisticated as economies change.
How much is a ticket?
I think $2 or $3.
Oh, okay. And so how does like the company make a profit? They
They
take.
keep the leftovers.
Oh.
Yeah.
because Chloe, like times that number by 3, and then it would be way more than what that is.
Well, I'm just trying to make it easy.
Okay, here's one that's gonna, a bit more interesting. The probability you get 4 out of 5 white balls correct, but not the Powerball. When I say not the probability, it's not the red ball. Probably means the red ball. Much more likely.
More likely?
Mm-hmm. The least likely thing is getting the jackpot. It's the least likely thing. It's 1 out of 5. How would we find this?
Let me ask you did the full, or the, you do the 69 C4, and then again for 69 C5.
Kind of. We've got to think through that. Yeah. So why 69 C4?
Because you're trying to get that many out of 5.
Because that's a probability.
5 of
First of all,
them.
number of ways, not probability, but number of ways.
Ways.
How about I go back a step? Let me do this one. Here's how we could calculate this. We know it's 1 out of 292 million, but here's how we could calculate it. Out of 5 winning white balls, we choose 5 of them. And that's out of 69C5. And out of 1 winning Powerball, we choose 1 of them, and that's out of 26C1. Because 5C5 is actually 1, and 1C1 is actually 1. So there's 5 winning balls, we choose 5. There's 1 winning Powerball, we choose it. This is how you can win the jackpot. Yeah?
Why wouldn't they have 69 of the Powerball and then 26 for the white? Would that make it more complicated again, or?
I don't know. Having 1 Powerball is kind of
Oh, so
magical.
you do 4C5. Oh.
5C4. Out of 5 winning balls, we're choosing 4 of them.
Oh, okay. And then over 69. Can you tell
Almost.
me what the thing is on the video footage that don't pick Powerball instead? Is it play stock market?
It is.
Okay.
But this isn't quite complete. What's it missing? The complement. If we're picking 4 winning balls, we're also picking 1 loser. You have to account for picking 1 of the wrong balls. So here's picking 4 correct balls. How many incorrect balls are there? Well, there's 64 possibilities, 64 possible losers. We choose 1 of them.
Oh, 69, 5.
5 of them are winners. We can't count those. Here's the 64 losers. So out of 5 winners, we choose 4. Out of 64 losers, we choose 1. And that just accounted for the white balls. Now we've got to do it for the Powerball also, the red ball.
Are there ways to like calculate smart number for that?
No. People think there are, but not really, no. Not it's truly random. Huh? So then here, how many losing Powerballs are there? 25. I have 25 losing Powerballs. We choose 1 of them. So you have to deal with the event and the event's complement. Okay? Picking 4 winners means you're also picking 1 loser. You can't just count the 4 winners because you're actually picking 5 balls, not just 4. But there's more ways to choose 4 balls out of 5 than there are 5 out of 5. Right? Because you can choose, there's 5 balls, you can choose these 4, or these 4, or these 4, or these 4, or these 4. There's 5 ways that can happen. If it's 5 out of 5, you can just pick those 5 and that's it. There's 1 way that can happen. Okay, any question there? So, say you play the lottery, not even Powerball, just any lottery. And over the span of a year, you put in like $100. Then you make 20. You got 1 scratch hit that made you some money. Well, then what really just happened there is you lost $80. People think, oh, I made 20, but no, you lost 80 because you spent 100, but only got 20 of it back. You lost $80. If you play the stock market and you just randomly put money in stocks, like you randomly put money in lottery, just randomly, don't even try and pick smart stocks, just pick 4 random stocks and throw money at it. If you make any money, like suppose you make $20, you actually have $120 because the 100 you put in is still in there. You can still get that out. Okay, that's the difference between an investment and a gamble. With a gamble, the money's gone. You hope to get it back. With an investment, the money's like with stocks at least. The money is yours. You can get it back if you want to, but it can grow.
You can still lose.
Then you can still lose, but with lottery, you pretty much lose, right? Like you can still lose, but the chance of winning is so much greater, and the chance of losing it all is so much less. People get sucked in by the fact that you can win $1.2 billion with the lottery, but you're not going to. Okay, you're not. It's not you. It's somebody in Florida. It's always somebody in Florida. It's always somebody in Florida or Texas or New York because they got big populations, right? Like you have just as good a chance as somebody else does. It's not you. Okay, don't play the Powerball. Play the stock market. Questions, thoughts?
Wait, so you're more likely to pick random stock.
To make money, yes.
Yeah, but
But then what you can do is not randomly pick stocks, then start actually investing or thinking things through or like doing research. But if you're gonna throw $100 over the course of the year at scratches or at lottery dollars,
I love
throw those $100 at Apple. You know, that's something that can actually make you money. Now the difference is sometimes you have to pay fees to do that. You have to pay a fee to put money into stocks. But if you like when we opened a new account recently, and I just called them up like a trading account, and I called them up and I was like, can you just give me like 50 free trades? And he was like, well, why? I was like, because I want to start trading and I don't want to get fined. I get to pay a fee every time I do that. And he was like, okay. So I got 50 free trades. You know, it means every time I want to buy or sell a stock, I don't pay a fee.
Is it just like
50 times?
50.
So you got to buy 50 stocks.
Or sell 50 stocks, yeah.
So
Just because I asked her.
so just like encourages them being okay.
Yeah. Really, it encourages the company. They want me investing with them, through them. So give me a few free ones and you can go from there. And pretty soon, if you're good enough at it, you can start making enough money to where the trades make you enough you don't care about the fee anymore. Paying like $2 to make a trade is worth it. You're making $2.
Do you have to go to a company or can you do it yourself?
I have to, and you will probably have to if you start. But I think you can get to a point eventually where you don't have to. I don't actually know. Because I don't know. That's all I know how to do it. Maybe I can find some other option, but I don't know of any.
So is it just like the stocks or you don't know how to buy them?
The latter. Yeah.
What does it mean when it says what combination of men and women is most likely to happen? Like,
I'm just going to rephrase it. Which combination is most likely to happen? Like if you're randomly picking men and women, what do you think is going to happen most often? Figure it out.
So this isn't like one of these seven sequences.
It's one where you might set up a few C things. Like Lauren, if you were just to randomly pick the men and women, what do you think is most likely to happen?
8 men, 6 women.
And why do you think that? Why is it about right?
Because that's how many would go to 14 and there's more men than women.
Good, so that's reasonable. Like that was a decent justification. And find that probability, and then maybe see if something else has a higher probability. Any homework questions on last night's homework due today, homework we're working on now, any questions at all on anything? Yes? Which was which?
So if that was a circle.
Ah, yeah.
Oh, yeah.
I actually got that.
Let's say there's, I don't know how many dots there were, let's say there's 10. I don't know how many there are, let's say there's 10. Well, I can pick any four dots give me a quadrilateral. And it doesn't matter what order I pick them in. I can pick any 4 dots in any order. So out of 10 dots, I'm choosing 4.
Oh, if you
Yeah, because it doesn't matter the order I pick the dots in. So the other one was the slope of the line. And there was, I think, 8.
But if that was not a combination.
Suppose I pick these 4 dots. That gives me this parallelogram, or that quadrilateral, right? Now, suppose I pick these 4 dots. It gives me that quadrilateral. The order doesn't matter. It's still the same shape.
No. But for the line, the slope, the order matters,
Oh, no. Suppose I pick these 2. I get that slope. Suppose I pick these 2. I get that slope. That's why with the slope formula, you can put it in any order, right? y2 minus y1, x2 minus x1 is the slope formula. You can switch x1, y1, or x2, x1, x2, because the order you pick them doesn't matter.
Isn't it kind of because if I crossed over?
If you chose to connect based on the order in which you picked, then it would matter. So like if me picking these 4 dots caused me to draw lines in that order, then it matters. But if you're just picking 4 dots and connecting the outside, then it doesn't. So it depends on the manner in which you go about connecting the dots. And that's why, like, I talked about specific language matters and then can make a difference. Like, the way you do something affects whether or not the order matters. You have to be very specific with how these definitions go.
87.
Which one was that?
The one about swimmers.
Yeah, okay, there's 8 swimmers on the team total,
Yeah,
and you're going to choose 3 of them.
and they have to be the strongest one.
And the order doesn't matter. So out of 8 swimmers, the coach is choosing 3.
Would that be times 8C5?
Why?
They're not choosing 5.
Ah, fair. But that would assume we're picking all 8 people eventually. But we're not picking all 8, we're just picking 3.
Why would it assume you're not picking the order?
Because this number here is how many people you're actually picking. Like, this is how many options you have. This is how many you're picking. We're only picking 3 people. So I don't have to worry about the 5 we didn't pick.
Oh.
So, that's 8C3 on the bottom, that's the sample space. On top it's 3C3. 3 good swimmers, we want to pick those 3.
Okay, that's what I have it on mine.
So don't start confusing counting with probability. Probability involves counting twice, dividing them by each other.
So wait, why do we do 3, 2, 6?
He is picking 3 swimmers out of 8. That's a sample space. But the question was, what's the probability he picks the 3 best swimmers? So out of the 3 best swimmers, he's got to choose all 3.
So
No, see, this is not a probability. That's a number. It's a number of ways something can happen. So there's one way this can happen. I grab the best 3 swimmers.
okay.
That's the only way that can happen. This is a number of ways that anything can happen. The division of the 2 is what gives me a probability. You divide the 2 numbers to get a probability. Yes, Cameron?
So the final one is
3C3 divided by 8C3. No. It's this.
oh, for the combination.
Yeah, combination.
Oh, comedy.
Oh,
Oh, oh well, you get it now. I was on Magic Pen.
We're gonna give some more more.
Yeah. No, we're done now.
Can you go over CD on the home test?
Like, well, 1A, 2A, 3A, 4A, 4B? Which one was it? 1B, which is the committee.
Yeah, in how many different ways could 8 women be chosen?
Out of how many women are possible?
Huh?
How many women are the total?
10.
So it's just 10C8.
But then,
That's why I said ignore men. Just picking women.
no, I think you said the SS is always on the bottom. That's what
Correct. But that problem was asking for a number of ways something can happen.
Yeah.
Not a probability. When you want a probability, that's when you divide by your sample space. And this is the common mistake people make, because finding a combination has division in it, so it feels like a probability, but it's not. It's just counting the number of ways something can happen. Yeah?
I hate myself. That's why I did choose that one.
Okay, what else? Yeah, cool.
wait, was
Can I
something
water?
wrong with the worksheet?
Another video quiz. Huh?
Your water.
I
Yeah.
I would.
Oh, that makes me so mad. Just a mistake.
Oh, wait, I do that.
Sure.
There's a one there, like, how many people want the worksheet?
Choose out of it.
Julian, do you?
Oh, no.
I don't need it.
Oh, wait, no, it's on the, just kidding. Cause I have to submit.
It's gotta be submitted, yeah.
But I like SS on the bottom.
Correct. Whew.